The first thing we're going to talk about is the mean, which is something that I'm pretty sure you already know how to calculate. But I want to make sure we understand how these formulas work, because we've got a lot of complicated formulas coming up with things like this big sigma, so I'm just going to break down this formula so that you can understand it. So we can see on here that we're trying to find the mean of x, which is symbolized as x bar. That's how we would say this, because it's got this bar over it, this straight line over it. That's referring to the mean. It wants to take the mean of x, some variable x. And what we're going to do, we see the first thing in here is we got 1 divided by n. What is n? N is equal to what we call the sample size. It's the number of numbers. It's how many observations we have. And so we're starting to build this mental image with this formula. We have some variable, x, and we've got a bunch of numbers that go into that variable, a bunch of measurements that we've taken for that thing. And this is telling us that we're going to have n of those. However many we have, that'll be n. And you can see that also here on top of our sigma. So what is this? This is the capital letter sigma from the Greek alphabet. And this tells us that we're going to do a summation. We're going to add together a bunch of values. And what is next to the sigma tells us what we're going to add together. We're going to add together the values of x. And you see we have this little sub I here. This is our index. This is telling us which value of x we're talking about. And now we get to what the things above and below the sigma are talking about. This down here tells us where we start. We start with an index value of 1, meaning we're going to start with x1, whatever the first value in our variable x is. And we're going to add up all the values. We're going to add up x1 plus x2 plus x3 plus x4 all the way till we get to the last value, xn, whatever that is. And once we add them all up, then we got to remember that we're dividing by our sample size, but that's how we do it. So that's what this formula is telling us. So let's do a quick example. I'm sure this will all be very familiar to you. That if we want to calculate x bar, we're going to do 1 over n. And so we have x here. So we can see this is our variable x. We have 1, 2, 3, 4 numbers in x. So n is 4, the number of numbers. And then we are going to multiply that by our summation, that we need to add together all the values of x. And those values are x1, which is 2, plus x2, which is 4, plus x3, which is 6, plus x4, which is 8. We add each of those together. That's going to give us 1/4 times 20. When you add 2 plus 4 plus 6 plus 8, you get 20. And 1/4 times 20 is going to be 5. That is our average. That is our mean of x. So what exactly is it? What exactly is the mean? What does mean mean? Well, the mean is an unbiased measure of central tendency. What do we mean by that? This is a really important word for us, unbiased. It has a specific statistical meaning, which is that I can subtract 5 from each one of these values. And I'd get -3, and then -1, and then +1, and then +3. And you'll notice that if I add these numbers up, -3 plus -1 plus 1 plus 3, we get 0. Which means this is what we would call our error. That if we were to say, hey, what do you think the value for x is? The best guess that you can make is 5, the average, because your error on average itself will be 0. 5 will be an incorrect guess all 4 times, but it will be correct on average. So if we had a bet, who's closest to the actual value? If I choose 5 every time, I'm guaranteed to be closer to whatever value we have for x over many guesses than any other number that you might guess. So any other number that you might guess, you will, over the long run, lose the bet to me more often than I lose the bet to you if I just guess the mean. So that's what the mean is. It's our unbiased measure of central tendency. And now you know.